Welcome back to the deep dive. Ever find yourself, struggling to get a clear quote for plastic parts?
Oh, yeah. It happens all the time.
Today we're diving into exactly what you need for a killer injection molding inquiry. Think of this as your fast track, yeah?
Exactly. Getting it right up front saves so much hassle. Ambiguous info just leads to delays, wrong prices, potential disasters, really.
Oof, nobody wants that.
Yeah.
So our mission today,
It's to pull out the absolute must-haves, so your RFQs are sharp, effective, and get you those successful manufacturing partnerships. We're looking at a pretty solid guide here.
all right, let's get into it. First up, the part design itself. It's visual, but it's also about, can it even be made?
Precisely, and that starts with the 3D CAD file. It's fundamental.
Okay, 3D CAD. Why is it so essential?
Well, it gives the full picture, the complete geometry. It lets the manufacturer run what's called a DFM analysis designed for manufacturability.
DFM. To see if the design actually works for molding.
Spot on. And, stick with STEP or IGS files if you can. They're much richer in data than, say, an STL file.
Yeah. STEP or IGS, got it. Better for mold planning, core, cavity, all that stuff.
Yeah, exactly. And calculating material volume accurately.
Okay, so 3D is key. But what about old school 2D technical drawings? Still need them?
Oh, absolutely. Don't skip these. Think of 2D as the crucial annotation layer on top of the 3D model.
Annotation layer, like what?
Critical stuff, like specific dimensions and, importantly, their tolerances.
Tolerances. That's the acceptable wiggle room for a measurement, right? Like plus or minus 0.1 millimeters.
Exactly. Vital for ensuring parts fit together correctly. Also, surface finish specifications, how smooth or textured the part needs to be.
Surface finish, like using those SPI or VDI standards.
Precisely. And you put all this on the 2D drawing, usually a PDF. You might even highlight, say, up to 5 critical to quality features, the CTQs.
CTQs, the really important bits.
Okay.
And maybe. Part weight. Is that helpful?
Yeah, definitely. Even a rough estimate of part weight or volume helps speed up the material cost estimation. It's a good head start for the quoting team.
Nice tip. Okay, let's shift gears to materials. This seems critical.
It is. The plastic resin choice impacts everything. Performance, how it's processed, mold design, cost, everything.
So I can't just say, make it out of plastic.
Definitely not. You need the specific resin type and grade. Saying ABS isn't enough. Different grades have wildly different properties like heat deflection or strength.
So I need the exact grade, or at least the performance specs it needs to meet. Like if it needs to withstand certain chemicals or temperatures.
Yes. Think about the application. Is it going outside? Does it need to be super strong? That guides the material choice, maybe ABS, maybe nylon, maybe something more specialized like PEEK.
And if you're unsure,
talk to the molder. They have the expertise. Also, don't forget color.
Right, color. Just saying blue isn't good enough, I guess.
Not really. Use standard systems, Pantone, PMS for branding, or RAL for industrial colors. Even better, provide a physical sample for them to match.
Physical sample. Good one. What about additives, like making a flame retardant?
Crucial to specify. Additives enhance properties, UV inhibitors for outdoor use, flame retardants often needing a specific UL rating, glass fibers for strength.
You need to list the additive and the spec, like ABS with UL 94V8.
Exactly. And just be aware additives can change the base material properties. Glass fiber adds strength, sure, but it might also make it a bit more brittle or prone to warp.
Trade-offs.
Okay.
And certifications, like FDA approved.
Yes. If you need compliance, FDA, medical grade like USP Class 6, RoHS state it clearly up front. It affects material grades, testing, and cost. Big time.
Okay. Design, material. Now, how many parts do you need? Production volume.
Super important. Your volume drives the whole tooling strategy and the price per part.
So what numbers do they need?
Well, the total quantity for the project is a start, but the really key one is the EAU, estimated annual usage.
EAU, why the annual number?
Because it tells the molder what kind of tool makes sense. Low EAU, maybe an aluminum prototype tool. High EAU, you'll need hardened steel, maybe multiple cavities to make parts faster and cheaper per piece.
So EAU dictates mold complexity and durability,
Duh.
like P20 steel versus H13.
Precisely. Higher volume justifies that more expensive, longer-lasting tooling, bringing your per-part costs down. Also, mention your typical order or batch size. Helps them plan production.
Got it. EAU is key for tooling and price. Now let's nail down quality, tolerances again, and finish.
Right. Define your expectations. We talked about tolerances on the 2D drawing. If some dimensions are absolutely critical for function, you need tighter tolerances than standard commercial ones.
And flag those as CTQs.
Yes. But be sensible. Tighter tolerances mean more expensive tooling and potentially higher scrap rates. Only specify them where they are functionally necessary.
Don't go overboard if the design can handle a bit more variation. What's typical, roughly?
Commercial might be plus minus zero point 0.1 to 0.7 millimeter, depending on size and material. Fine tolerances, maybe down to plus minus 0.025 millimeter. It varies.
Okay. And surface finish. We mentioned SPI and VDI.
Yep. These standards define the texture, from high-gloss mirror finishes like SPIA, down to rougher matte or textured finishes like SPIC or DVDI is another common standard.
And you specify this on the 2D drawing, too.
Absolutely. It's achieved by treating the mold surface itself. Keep in mind, glossier finishes often cost more, and not all materials take every finish well.
Good points. Okay, let's wrap this up. What's the big takeaway here?
It really boils down to this. Being comprehensive and precise in your inquiry is just foundational. It sets you up for a smoother project, a better partnership. Clarity avoids so many downstream problems.
So for you listening, remember that those details, tolerances, the exact material grade, the EAU, they directly hit your wallet and the quality you get. Knowing this stuff puts you in the driver's seat.
Yeah, absolutely. Which leads to a final thought to chew on.
Go for it.
Think about this. How could one tiny detail, maybe overlooked in your RFQ, ripple outwards? How could it affect the final part, the cost, even your relationship with the manufacturer? And maybe, what other parts of your business could benefit from this kind of detailed, proactive thinking?
Interesting question. Definitely something to consider. That's a great place to end our deep dive for today. Hopefully this gives you the ammo you need for your next injection molding inquiry.
Hope it helps.
Until next time on the Deep Dive.